So for my presentation, we're going to take a look at the Kaikoura Canyon and investigate how tectonic activity creates and disturbs sites of biological production on the ocean floor. So for this presentation, we're taking a field trip to the South Island of New Zealand, where we're going to use Kaikoura as an example to investigate the importance of submarine canyons as biological hotspots and think about the relationship between bathymetry biology and tectonics. So first, we're going to take a quick tour of the region, discuss the features that make submarine canyons powerful bio hotspots, and then we're going to take a look at the 2016 Kaikoura earthquakes and how the massive tectonic activity associated with the region's geology impacted the marine life offshore. So first, a little bit of overview of New Zealand geology. So New Zealand lies on the boundary between the Pacific and the Australian plates. So the Australian plate is that less dense continental crust, and beneath it is the Pacific plate. By beneath, I mean subducting underneath it. The Pacific plate is that denser oceanic crust. You can see on this diagram to the left, there's this Hikurangi trough that's created by this subduction zone. And where that trough meets up with the South Island, that's where we're going to focus on. So zooming in to where that trough intersects the South Island, like I pointed out, you can see the Hikurangi channel, which are where those ocean currents have cut this channel into the seafloor. And if you follow that channel all the way to the continental crust to the left, where I've got that red circle, you can see that it's created this network of deep canyons. And this canyon that I've specifically circled is the one we're going to be talking about today. So in this region, there are a lot of active tectonics, which makes sense, subduction zone, all that, which means there are a lot of major earthquakes. And there's actually a mountain range also associated with the subduction zone that's right on the coast. And with these shaking events and with a lot of rainfall, you get a lot of sediment that's flowing from the mountains into the ocean and right into that canyon. So Kaikoura, zooming back out a little bit, some background. It is really categorized by this mountain range, and then in the ocean, this abundant marine life. And it's really important to everything about Kaikoura. Kaikoura actually means a meal of crayfish. So this idea that there's this abundant marine life, this abundant healthy biology in the ocean is really important to the culture. This canyon's only about 600 meters offshore, and it's a year-round feeding ground for sperm whales, dolphins, orca, seals, paua, royal albatross, humpback whales, all kinds of marine life. Some of the features that make that marine life thrive so well are associated with that deposition from the ocean into the canyons. So this figure on the right kind of shows how the canyons got this perfect U shape. Actually, the walls of the canyon are about 10 degrees steep or less. And the debris just kind of flows right from the land into the canyon and settles. The canyon gets between 900 and 1,100 meters deep. And in this next video, you're going to be able to see a little bit about what the floor of the canyon actually looks like. You can see it's a lot of fine, silty muds. You can see there aren't like ripples from the current or from wave action that are disturbing them. Once the sediment settles, it's kind of still, and it's so nutrient rich, and you can see how much marine life it's supporting. It's accumulating about 2 times 10 to the third tons of biomass per year. And as a result, the biological production of the Kaikoura Canyon region rivals the entire East Coast stock of New Zealand fisheries. And you can see that is a much greater area, but just the specific geology that accommodates for the accumulation of so much biomass makes this area more productive than basically the rest of the East Coast. So going back to those shaking events, in 2016, there was quite a large one. It was a 7.8 magnitude earthquake at a 15-kilometer depth, so it caused major disruption. It actually raised the seabed on the coast up by between 1/2 and 2 meters, so a lot of the coast you'll see today was actually underwater before these events. And the effects, they weren't just on the infrastructure and on the coast and the land, but there are also a ton of effects in the underwater landscape as well. So we're talking about big mudslides, turbidity currents, and canyon flushing. And that canyon flushing is the disruption of those sediments in the canyon. So the paper that I really looked at to investigate this further is called Changes in Habitat Use by Deep Diving Predators in Response to Coastal Earthquakes. It came out in 2020, and they used a multi-year data set to compare the behavior of sperm whales before and after the earthquake to see what the effects of the marine life from the earthquake really were. So they monitored the diving locations, surface time, foraging locations, all kinds of things from January 2014 to 2018. And they also monitored their diet by analyzing samples of sloth skin. So the focus was really to examine this relationship between the shaking event and marine predators and what the impact of those landslides and that, flushing of those settled sediments out of the canyon, what that was. And this was really the first study to look at that kind of relationship, which I think is really cool. And their results, they found some pretty interesting things. They found that the time the whales were spending on the surface increased by about 25% in the year after the earthquake. It's not that the whales needed, more time to rest or breathe necessarily, but maybe that they were having trouble navigating such a transformed landscape and they were having a harder time finding food in this feeding ground that they use year after year. The skin samples did not reveal any major change in diet, which is good. At least they were still able to find the food that they needed or roughly similar food, just in different areas. So it was mostly a change in habitat use. One thing that I think is so interesting about all this are how plentiful the Kaikoura Canyon is and how understudied submarine canyons are in general. Kaikoura just specifically has been studied intensely for decades, but as we know, this is not the case for the rest of the ocean floor and certainly not for canyons. Only 15% of the about 660 canyons that we know of in the ocean have similar characteristics to the Kaikoura Canyon. So we don't really know how productive these canyons are, but if we're taking Kaikoura as an example, we can assume that they might be really important bio-hotspots globally and have a lot of importance in global ocean health. So some things I think we can take away from this example are just that there is a really active relationship between tectonics, bathymetry, and biology, and that relationship should be explored more. Also that the benthic biomass that accumulates in these canyons creates massive biological productivity, and the importance of that shouldn't be undermined. And finally, that further study will probably show that the impact of tectonics on the Earth and the ocean's productivity is much greater than we thought, and that when we think about these shaking events, we should be thinking about the effects, not just on land to our infrastructure and to human health and to terrestrial environments, but also to marine environments. Here are my sources, and thank you.